Hello and welcome to the 2024 Chromosome Analysis Course presented by the Society of Australian Genealogists. My name is Veronica Williams and I'm going to be your course presenter for the next few months over the 12 modules that we are going to be meeting for this course. I'll be supported by Lisa Byrne and Vicky Hales, who are also experienced DNA researchers at the Society. As far as I'm concerned, a little bit about me. I've been involved in family history research since about 2006 and completed the SAG Certificate in Genealogical Research back in 2010. I was very pleased to be appointed a Fellow of the Society last year for my contributions to the Genetic Genealogy program. My professional background was in public administration and I had a focus of human resources and change management, and I hold a Bachelor of Management degree. I first tested in my DNA in 2010 with Family Tree DNA, and you can see there a picture of me back then. I look a lot younger. They encouraged us to take that photo in those days. They don't seem to do that anymore, not as much of the novelty, I suppose. I was instrumental in establishing the research group at SAG in 2015, as we didn't have very much material around then and it was very difficult to learn anything here. And so it was a way to get to meet other researchers with fellow interest. I also undertake volunteer work for WikiTree, which is a free family history website, and Family Tree DNA. I have a number of projects that I'm involved in that are listed there. You'll see me around the traps with this avatar. My username is GeneMonkey on most sites, and you'll see Veronica there. I also have blogs on WikiTree, WordPress and Blogger. I used to do Sudoku, but now I do chromosome analysis. And I think any of you who like logic puzzles will find that chromosome analysis can be a very addictive hobby. So as I said, the chromosome series will be going over a period of 4 months, and there's 12 sessions there that are listed as part of the series. The main reason for this recording is really that there are prerequisites for this course, and really it's about having a basic knowledge of DNA theory and spreadsheet skills and being able to research and analyse trees. This session is really just to go over some of the basic DNA theory to make sure that we have a level playing field and that everyone's at the same point. The SAG has this DNA learning pathway, how we recommend people should progress their DNA research. And you can see that chromosome analysis is right at the end there. So when you're undertaking this course, we're assuming that you've completed the other modules and courses before this, and in particular the analysing your ancestry DNA results gives you a much better grounding in some of the key concepts and steps in the DNA methodology. And you have the DNA framework here, which is really the course modules are modelled around this basic framework of 4 different aspects. And the research methodology, we have a 7-step research methodology which fits underneath this that we'll be going through during the course. Most of you will have seen this slide from Christine Woodlands, which is covered in the Ancestry DNA course. In it's mostly around tree triangulation and looking at the total centimorgans shared with our cousins to be able to confirm our ancestry. Now this mainly relates to third cousins and closer, and you can see there that most of our DNA questions will be resolved through using total centimorgan approach and closer ancestors. But if some of you are looking for confirming more distant ancestors, validating your pedigree and things like that, you'll need to be doing chromosome analysis and segment triangulation. Now this is a lot more effort is involved in undertaking this type of work, and sometimes it really needs to be Y-DNA or mitochondrial DNA that answers the questions and gets you further back in the tree in terms of your DNA confirmations. But we're focusing on autosomal DNA here, so we're looking at this right hand side And the course will be covering segment triangulation. In fact, every module has an element of segment triangulation in it as we develop our understanding of what is segment triangulation, how we can see it, what's not segment triangulation, and that sort of thing. So really you need to be competent in the left hand side, and all the activities that are undertaken in the Ancestry DNA course are foundation research skills before moving on to working with chromosome analysis. Whilst we were talking about effort there in terms of trying to confirm ancestry, the amount of DNA evidence also is impacted by whether you have a paper trail or no paper trail. So on the left-hand side, tree triangulation and the total centimorgan approach is quite easy to validate ancestors where you have a strong paper trail. Where you have no paper trail, you need to have more evidence, and this is essential in terms of developing your hypothesis, and you may well need to move into chromosome analysis to be able to validate some of those people. When we're over here on the right hand side and looking at chromosome analysis and segment triangulation, the total shared centimorgans becomes less important. We're really looking at triangulation and evidence of a shared ancestor. But we do need much more evidence if there's no paper trail, and we need to have a lot more triangulated groups, which we'll talk about throughout the course, and really, as I've said earlier, why an mtDNA may be a better test to try and confirm that ancestry. So this is the overview of the series showing the 4 modules and the theory that we're going to be covering in those sessions. And you can see there in the module 1 that the first number of points that are there, there's 6 there I think, we expect that you already have that knowledge. New content is starting from in common with and going down that list, fully identical regions and half identical regions and segment triangulation. And you'll see there in that list that segment triangulation features in every module. There are some prerequisites. One of them is watching this video, and I also want you to read Roberto Estes's article and upload your results to the chromosome analysis sites. But there's more about that in your welcome letter. So in this session we're going to be going through some of these basic research terms and concepts, and there's 8 listed of them there. So hopefully you are familiar with all of this, but if you're not, please make sure that you take some time to get yourself up to speed on some of these issues before the course. As I said earlier, they are fundamental to being successful, and we won't be discussing them in detail. So the first is planning and research goals. Basically, you just need to be clear about what your DNA goal is. If you just want to validate your pedigree, or if you're looking to solve a family mystery, the approaches will be different. But the main thing is to be clear and to develop a research plan so that you outline what those goals are and that you test the right person, and that the approaches you take are getting you to where you want to go in terms of your research goal. It's very easy to end up down rabbit holes and spend a lot of time researching other red herrings that aren't necessarily going to take you to your main goal. And your research goal will drive which tests you take, and really it's the inheritance paths that will determine who is the best person to test to achieve that goal. Generally it's the oldest living relative, but sometimes the inheritance path might require a specific ancestor. You all probably are aware of our preferred testing transfer strategy. We recommend that everyone starts at Ancestry DNA mainly because of the size of the database that they have there and the extensive family trees. Next, transfer to the chromosome analysis sites, and finally test at 23andMe. Ancestry and 23andMe don't allow you to transfer in, which is why we recommend that you test at those sites. As far as chromosome analysis goes, not all sites are the same. Ancestry DNA does not provide any chromosome analysis information, neither does living DNA. So really this course is going to be centred around the other 4 testing companies, and the main thing is to work with the kit that is likely to have the most relevant DNA. So in my case, my mother's tested but my father has not, so I would generally be working with my mother's kit for my maternal side, and for my paternal side I'd just work with my own and ignore all the maternal matches. The next point I want to make is the fact that we have 3 DNA tests that we can generally take and 4 types of DNA. I've suggested in the pre-reading that you read this blog from Roberta Estes about the 4 kinds of DNA, and it's a bit dated, 2012, but it's still the best explanation of the 4 types of DNA and the 3 tests that we can take for genetic genealogy. You'll have all seen this slide before, I'm sure, which shows the 4 different types of DNA that we have. Autosomal DNA, which is chromosomes 1 to 22. What we call the X chromosome, which is actually also autosomal DNA, but is chromosome 23, is the second type of DNA. Thirdly, we have the other sex chromosome, the Y DNA, which is only applicable to males. And fourthly, the mitochondria DNA, which is handed down by women, but to both men and women, their sons and their daughters. So the first test is the autosomal DNA test, which is ones like Ancestry, MyHeritage, Family Tree DNA, etc. And both the autosomes 1 to 22 and the 23rd chromosome are tested at all these companies, but a number of the companies don't report on it. The second test, of course, is the Y-DNA test, which is a completely different test for males, and the mtDNA test, as I said, for mitochondrial DNA. And it's important to know how these particular tests are inherited, or not the tests, but how the actual DNA is inherited, and it's different for the 3 different tests. The autosomal DNA covers all your ancestors, so it's much harder to work out where the particular segment of DNA is coming from. Whereas the Y-DNA test and the mitochondrial DNA test are specifically handed down through the patrilineal line for Y-DNA and from the matrilineal line in the case of mitochondrial. The only difference being everyone gets it from their mother, but the mother passes it down to sons and daughters. For our purposes for this course, we're focusing on AtDNA, or AuDNA as it's sometimes referred to as the autosomal DNA. As I said earlier, it might be useful for more distant ancestors to be looking at Y-DNA and mtDNA tests, because you can get back much further and more easily with Y-DNA tests and mitochondrial tests. Finally, I'd like to talk a little bit about the 4th type of DNA, which is the X-DNA, and also from the 23rd chromosome. And you'll see these charts around. They show you the unique inheritance path of the X chromosome. So women have 2 X chromosomes and they get one from their mother and their father, but the men only have one from their mother. And so there's this unique pattern that emerges in terms of how that's handed down. So if you have a match on the X chromosome, you can eliminate a lot of your tree depending on how it may have been handed down to you. Now, we can only view these segments at Family Tree DNA, 23andMe and GEDmatch, but we'll be talking more about these. One of the things I suggest you do is to print out your pedigree on an X-DNA chart. I got this one through Charting Companion. It's not as easily recognisable out to 254 generations of typing. The font's not that great, but other programs may do it better. But I'd suggest that you have one of these so that you can actually be aware of when the X chromosome might be useful to you. but we'll cover that more in Module 8. I don't know what I'm talking about. That's actually Module 3. Sorry about that. In the next section, we're going to talk about autosomal DNA terminology. And you're probably all very familiar with most of these things I'm going to talk about. We all know about segments and centimorgans. Possibly SNPs are probably a little bit less familiar, but we don't really need to know much about SNPs in our research for segment analysis. Key terms are shared centimorgans, which we all know are as a measurement of distance. Some of the new terms might be things like identical by descent, identical by chance or state, or identical by population, and these are terms that refer to the segment being handed down, but we're going to talk about that a lot more throughout the course. So segments are a continuous piece of DNA measured in centimorgans. We get them from our ancestors and they're shared with DNA matches. So in our research we're looking for shared segments that are passed down from common ancestors, and that's what's known as IBD, or identical by descent. Some segments may be inherited by chance, or they just look like matches, often referred to as false positives, rather than being handed down by an ancestor, which, as we just mentioned, were identical by descent segments. And some segments may be handed down by an ancestor, so they're IBD, but they're so old that they're not in the genealogical time frame, and we often refer to these as IBP, or sticky segments. And these are some of the ones that Ancestry takes out with their timber algorithm that you may have heard about. So in the course we're going to cover IBD, IBP, IBC and IBS segments, false positives, and that will be covered in Module 2. So as far as centimorgans go, we don't really have to worry too much about it, but we just need to know that bigger is better. And with SNPs, these are the comparisons at the different locations along the genome, and there's something like 700,000 of them, A, T, C and G. So it's where all those things match. And MyHeritage has a term called the reference SMP, cluster ID, and that you'll see on your downloaded match lists. And that's similar to the SMPs or SNPs that are shown in many of the other sites. We'll go through these when we're looking at the different way that different sites report on their results. But once again, don't worry about these, just remember that bigger is better. Now, just a few reminders about cousinship and shared centimorgans. Back when we're looking at our shared matches at Ancestry DNA and we're looking at total centimorgans, we need to identify the most recent common ancestor based on the predictions for the shared centimorgans and the paper trail, making sure there is a paper trail. But our total centimorgans approach really can only confirm out to third cousins or closer. So for what we're going to be doing with chromosome analysis is looking at second great grandparents and beyond, which is the third cousin level, and we need to have chromosome analysis to confirm those relationships. Second great grandparents at Ancestry DNA can only be confirmed to the ancestral couple level, not to the individual, unless we've got segment analysis going back a further generation and ensuring there's segments on both sides of that couple. And normally we can use the predictive tools on the various sites, but there's also the Shared Centimorgan project. But just to remember that the ranges in this document are crowdsourced, so they can't be relied upon. We really should just be looking at the averages and looking at the numbers of possibilities that there can be for those predicted relationships, and the probability tables are probably the best place to look for different centimorgans, and you can get that on DNA Painter at that web address. Now, remembering that past third cousins, the probability of matching that drops off, and the shared segments are going to be much smaller. This chart that's been done by Louise Coakley quite a while ago now indicates the probability of matching cousins, and just a reminder, this is at the same testing company, because remember the different companies test different locations and they're not always aligned. Now, Ancestry has a program called Timber, which takes out potentially false segments, which gives it the higher probability rates. And you'll see sometimes the shared centimorgans at Ancestry will be much lower than what you're sharing at other sites. Now, that can be good and bad. They eliminate false positives, but they also sometimes remove actual valid matches. MyHeritage does something called imputation, where they add in segment data where they think there should be over particular places in the chromosome, and they can give sometimes higher shared matches, and that can lead to getting confused with whether a match is actually really a false positive, but it's being reported as a positive match or a matching segment. So past third cousins, you can still have a genealogical relationship, and all of these matches are great clues for your genealogy, but there's less chance of a genetic one, and we need to be certain that the match data is telling us what we think it's telling us in terms of confirming our ancestors, and that's where chromosome analysis comes in. So very few relationships with DNA can be proven, except for perhaps close relationships like parent-child and sibling relationships. You can see there that they're pretty much 100% of the time they're going to match at those levels. But when you're looking at smaller matches, and this is an example of a 25 centimorgan match, there's all those possibilities that aren't shaded out that could be how you're matching this person. So we've got to be a lot more careful. So the message is not to assume without more evidence. And without both you and your match having full, robust, researched trees, you may not recognise the surnames that you share. But we'll be covering this a lot more in Module 4. What I want to talk about is recombination and what I call the DNA lottery. Hopefully all of you understand how autosomal DNA is handed down through the generations, and this is a chart you've probably seen before in terms of DNA coming down. So we've got there an image of, grandparents and parents and 3 children, and so it is a bit of a lottery to see what each child will get, and the 3 children can potentially end up with very different DNA mixes on the chromosomes, but they still come from the same base pairs at the grandparent level. So we need to understand that, and from chromosome analysis point of view, what we're doing is working backwards from the child and validating that segment came from the parent and the grandparent, etc. Autosomal DNA and the process of recombination again quickly. Okay, so we've got the mother and the father with a paternal and maternal segment from their parents, and that gets handed down to the children on 23 chromosomes, and the child gets a mix of the father and the mother. In the ideal world, it'd be 50%, but we know that doesn't happen. As I said, there are 23 chromosomes, so we've already talked about that, and the 23rd chromosome is different for men and women. Women have a pair of X's and men have just one X, and the Y chromosome is tested separately, as we spoke of before. So in those 23 pairs, we know we get a random amount from each of our parents when the segment is recombined and handed down. But what part do we get? It's very random. So it's random to the child and it's random on each chromosome. Remember, we've got 23 chromosomes. And in this example, we're just looking at one chromosome, and you can see there that we've now got the grandparent level in there, showing how those segments are handed down to the father and the mother of the child, and then subsequently by the father and mother to that child. And remember that siblings will get a different mix on every chromosome, except of course for identical twins. Now remember that the child can only inherit DNA segments from one of their parents, so it has to be shared with one of their parents. If the parents is tested, anything that's not shared if both cannot be from that side. So if you've tested your mother and you think it's a maternal segment but it doesn't match the mother as well, then it can't be. It's either the father or it might be a false positive. And so in this case we can see here that the father has inherited a segment from his grandfather and the grandmother and passed that down when he recombined his chromosomes, passed down to the child, and the child's got a little bit of each of those grandparents, both the grandfather's parents and both the grandmother's parents. But when we look at the maternal side, you can see this child has only got two coloured segments in his maternal chromosome, his or her maternal chromosome, and you can see there that they got both sides of the maternal grandfather, but nothing was inherited from the maternal grandmother. And this can happen quite frequently at individual chromosomes. Of course, we know that children tend to get 25% of their grandmother's DNA, so it's not going to happen every time on every chromosome. So in this example, what we're wanting to look at is that segment of blue there. So what we're trying to do in chromosome analysis is work out where that segment came from. And you can see that this one goes back to the father and this one goes back to the paternal grandmother. So, but then on the next generation, who does it belong to? And it's the process of reviewing our matches, our trees, and the segments to be able to determine this. Think about how many individual segments there can be when you go back 7 generations to fifth cousins 23 times. It's a lot of information. And we expect autosomal DNA to reach back around the fifth cousin level, although it gets harder to identify those back there. So the further you go back in time, the segments you inherited from your distant ancestors are going to become smaller, or you may have inherited none at all. And that's quite common, particularly as you go further back. And this is a chart that Jim Bartlett put together many years ago now, which is showing your genealogical tree versus your genetic tree. And you can see there that closer in time, on that fan chart there, you can see the closer ancestors are quite dark in colour, and which is suggesting that, 99, I've got there at the first great grandparent level and second cousin level, 99% of the time you're going to match those people. But as you go further and further back, the chances of matching starts to drop off, and at third cousins it's only 90% to 98%, but by fifth great grandparents or sixth cousins you've only got a 2% chance of matching, and in some cases you're not matching at all. So all those white gaps there are people who are not matching. So the message is try and test as many people as you can. Known relatives, they don't have to be your direct line. They can be other relatives that you've come across in your research. And being able to use their test results will help you to get back further in time, even if you didn't inherit any of that particular DNA. But we'll talk about that a lot more when we're doing the course as we move through. Another thing we need to remember is about our pedigrees and tree completeness. Some key messages about developing your pedigree. You need to really build out your pedigree to at least 7 generations, because that's where we think autosomal DNA can reach. 5th great grandparents or 6th cousins. DNA matches are often predicted to be 5th cousins, but sometimes they're 1 or 2 generations out, as we know. So ensure you research out and down on your connected lines. This will help you to be able to match with other people, and particularly for tools like through lines and theories of relativity at MyHeritage. Unknown matches are probably connected to your unknown ancestors, so if you haven't got a full and complete tree, perhaps that's why you're not recognising some of those matches. And I keep a bit of a log about how I'm going with my tree completeness. I haven't done it this year, but usually I do it once a year, just to check that they're going up. And you can see there, even though I've done lots and lots of work on my tree, I still have 39% of those 254 ancestors who are unknown. I think I've found a few more since April last year, so I must do that again. But without both you and your match having complete pedigrees, you won't know if you are matching in those particular areas or not. About is DNA confirmations, colloquially known as giving your ancestors the tick. The message that I really want to give is that up to second great grandparents, you can only confirm those individual ancestors at that P1 to 8, M1 to 8 view with chromosome analysis. You can confirm your ancestors up to that level individually with close cousin matching up to as long as you've got a shared paper trail. And you may have matches at Ancestry DNA for those ancestors, those P1 to 8, PM1 to 8, but you're only confirming them with the total centimorgans approach to the shared ancestral couple on that outer ring. So I've got the darker green ring in there are the ones that can be confirmed, and then the one individually and the ones on the rim at the second great grandparent level are at shared ancestral couples only. And whilst you might have a high level of confidence in those ancestors because of matching further back on the line at Ancestry, you really need, in most cases, chromosome analysis to confirm those matches. If you've got 50 on one of them, it's probably confirmed, but you really need to have segments going back on both sides to be able to be sure that both of those people are confirmed as your DNA ancestors. And third cousins might only share about 4 to 9 segments, so it's important that you know that those segments are coming from both sides. Beyond first cousins, or where there is no paper trail, you obviously need to look at the segments before confirming your ancestors. Because many of those shared matches, as we all know, are further back on the line and may well be matching a different part of the line completely. Most of us have high levels of multiple connections, I should say, with people further back on the line that we just don't know about, and it all goes back to tree completeness, as well as a lot of the close communities such as Ireland and other places that relatives are connected further back on the line. And this is a map that I've done at DNA Painter, which I call my DNA confirmation tree, which is just sort of showing that in a different format in that, and I'm trying to colour in the ones that you can confirm at the individual ancestor, and the last level, which is the second great grandparents, which I believe with total centimorgans you can only confirm up to second great grandparents. But we'll be talking much more about this throughout the course and showing how we can actually do that. But you've always got a question, and it gets back to pedigree completeness and DNA confirmation. If you aren't having if you don't have all your first and second grandparent levels DNA confirmed, or at least to the ancestral couple, you need to be starting to question whether you've got the right people in your tree. And there's no point in going down the segment analysis path if you haven't confirmed your earlier ancestors yet. And that's your first priority. So focus on confirming up to the second great grandparents. If you've got gaps, try and work on those. You need to have a solid base before tackling more distance relationships with chromosome analysis. And this is just to show you my DNA confirmations that I've done so far, and one of those ancestors was identified from DNA, which I will talk about during the course. My big brick wall, of course, is my second great-grandfather, and I'll be using some examples of what I'm doing with his ancestry to try and find out who he is. He's a mystery man. And those last two there, James Murphy and Elizabeth Bateman, are only confirmed to the ancestral couple level only, and I hope to I haven't done much work on them because they're island, and I'm hoping to use them as examples throughout the course with new work that I'm going to start doing now. Just a few messages from me. So in traditional genealogy, we're always taught not to rely on the index and to always check the original. And there's a strong parallel in genetic genealogy. So total centimorgans and shared matches are clues, but segment triangulation is evidence. And it's a bit like primary sources versus secondary sources. You need to think about that. You may have enough information at the total centimorgans approach to develop a hypothesis, but to prove it, you need to go to segment triangulation, particularly for those more distant ancestors. So shared matches with tree triangulation, which is what you're getting over at Ancestry and other sites, a one-to-one two-person match is indicative evidence of a shared answer. But segment triangulation plus tree triangulation give you a much stronger case to argue that that person is your ancestor. And again, it's much more critical for distant relationships beyond second great-grandparents. And we're going to work on segment triangulation in every module of the course. So I'll give you some more clues about that. Methodology for our DNA research, which is outlined on this page here, so take some time to read that. We'll be working through these steps throughout the course. The course is modelled on autosomal segment analysis, but you should also be thinking about Y-DNA and mtDNA for those distant ancestors. Now, those of you who have already done the Ancestry DNA course, you've already covered steps 1, 2, 3 and 6. And you might recall that in the course Christine works through what she calls her three-prong approach, and it's about sorting fourth cousins or closer into groups of shared matches, or some people call them genetic clusters, researching those people to try and find common ancestors within each of those groups, and then looking at recording matches with common ancestors in what are the odds to give you that visual representation of how your matches are coming together. So having done the course, you should be familiar with grouping and genetic clusters such as those on the left. These have all just recently changed, so I've been playing around with those, so some of these aren't quite how I'd like them. And developing your tree high and wide, as we talk about, so that you can find those other names of your matches if you know more about their siblings and their descendants. And this will also help through lines and theories of family relativity at MyHeritage to work, and to look at those relationships in Watto. And whilst we're going to be covering steps 4, 5 and 7 in this course, in terms of what are the odds, it's not as reliable for distant relationships, and so I don't tend to use it as much as when I'm looking at close relationships, but it is good for visualization of where the matches are coming from. So we'll be using it to look at what our matches are telling us, not to assess the probabilities. But at the closer levels, you would be definitely using that. So remember, what we're trying to do all the time is to build additional evidence of our DNA confirmations, and this is a chart that we developed earlier this year that tries to outline the steps that you would take, looking at your total centimorgan approach, looking at shared matches, that sort of thing, making sure you've got a paper trail, then looking at further evidence through segment triangulation, and there is a blog post to support that. But don't worry about that too much at the moment, because that's what we're working towards throughout the course. But make sure before you come along to the course that you've maximised your groupings at Ancestry with the new Pro Tools. There are some excellent clues to be had by subscribing. I think most people have got it by now. It's $10. You can just do it for 1 month, and you may well be able to sort out some of those mystery groups. I've found I've got a lot more clues by looking at some of those mystery matches, particularly the large ones, because you need to make sure you know where they fit in your tree, because they could be clues of other unknown lines. And start to use those clues for a bit more tree building. And then trying to fit them into the family groups, because you've got a lot more information knowing how they match each other to be able to do that. The course. So module 1 will be revisiting some of these concepts just really very briefly, because hopefully by watching this presentation you will have caught up if you had any gaps in your knowledge, and taking questions. So I'll be taking questions, and the main new content will be segment triangulation. But I will be asking each of you to introduce yourselves and to talk for just 1 or 2 minutes about your pedigree as it stands and your DNA goal moving through the course. So be prepared for that. And then the remaining 3 modules are all about applying the methodology 7 steps. And that's what we'll be spending most of our time on. So just a reminder that chromosome analysis is the harder end of DNA research, and really you need to be quite serious, because it requires effort and diligence, and it's a long-term project. And to get most out of the course, you need to understand everything that we've covered in this presentation. And just a reminder that we won't be covering the topics that were included in the Ancestry DNA program. We're expecting that you have that knowledge, and but some of those aspects will be revisited for context. Now, there are some blogs around that you might find of interest. The ones on the left are my blogs. Gene Monkey Explains is where all the material for the course will be posted, and you'll find some resources there. The bottom one on the left hand side is my own blog, which has some articles about my research. DNA Sydney is a supporting blog for the Society's DNA group. Basically it's just a compendium of resources. It doesn't have a blog component anymore. And then there's Christine's Mozzie's Musing if you need to catch up on any of the Ancestry DNA course concepts. So chromosome analysis is hard work, but it is quite fun, and remember that we sometimes might have to trace out those 20 centimorgan matches back as far as the Mayflower, and then go across the pond and down to where our ancestors are a lot of the time in the United Kingdom. So that's it from me, and looking forward to working with you all soon, and hope to see you on the 13th of July. And happy to answer any questions before then. There's my email address on there. Just drop me a line. Thank you, and thanks for your time today.